This is on page 39. We're good? So what is this all about? What is 39? And we're not going to spend a whole lot of time on this, but I need you to understand, and I have a feeling some of you did this in junior high, the tree diagrams or the outcome tables. But this is all about coming up with the total number of outcomes there could be when there's more than one event happening. So for example, I had an example of meals and different choices for drinks. And then so essentially it's like 2 times 3. It gives you the 6 different outcomes. That's the tree diagram. It could have been a lot more complicated. It could have done a meal, a drink, and a dessert. Right? And so all you need to do is you need to just multiply, right, the total possibilities. In this case, we're up here, 2 meals times 3 drinks. So we had 6 different orders that we could make. We did the same thing with an outcome table. So tree diagram and outcome table they give you the same scenario, and we honed in again that we got 6 outcomes here. I did that right. Okay, good. So we're good here, 6 outcomes regardless of how you do it. But I think in general, I just want you to know this. I hope you highlighted that box. If you ever need to figure out total number of outcomes, you go options of event number 1, multiply by options in event number 2, number 3, 4, 5, and so forth. So, and this could be password, right? Your first character, your second character, your third character, and so forth. Like if you make a password for your Facebook account, you can use what? You can use letters. But did you know that how many letters are there in the alphabet? 26, right? So if you have 26, but they could be upper and lower case, right? It's case sensitive. So technically you have 26 times and 26, so that's 52 options. But can you use numbers? 0 to 9, so that's another 10. So 52 plus 10 is 62 options for each character. But what else can you use? Special characters. So for a password, there's a lot of combinations, right? So keep that in mind. Phone numbers. How many digits do our phone numbers have? Normally 7, right? But then you have your area code, and it's 204, now it's 431 as well. So same idea, like we're talking millions and sometimes billions of choices. So it's kind of cool, I think, for me at least, to know this stuff. So here we go. 2 4-sided dice are being tossed during a game. How many possible outcomes are there? What is an alternative term for this? So possible outcomes, we will say this: outcomes, 6 sides, right? 6 sides for the first one die, and then 6 sides for the second one, right? So we would have 6 times 6 is 36 outcomes possible. You have 36 possible outcomes. What's an alternative name for outcomes? We just talked about it. Sample size or sample space. Sample size, right? So I'm going to circle it and say, hey, that answers that question. Create an outcome table showing the possible outcomes. So can you do this? I have a feeling you've done this before. So if this had been a 4-sided die, then this would just go 1, 2, 3, 4, and we stop there. But it's 6-sided, right? So you're going to go 5, 6 like that. And the same thing going down. 1, 2, 3, 4, 5, 6. 2 dice here. But I want to give you what's happening down the road. It could be that you roll a die and you spin a spinner with 4 colors. So you would have 1, 2, 3, 4, 5, 6, red, blue, green, yellow, right? Same idea. You could roll a die and toss a coin. So it'd be heads and tails. 1, 2, 3, 4, right? Like all the way to 6. So it depends on what's happening. So 1 and 1, you actually could do this. 1 and 1. Then you have 1 and 2 commas in between. 1 and 3, 1 and 4, 1 and 5, 1 and 6. I finish that row, I go to my second row. 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. Then it's 3 and 1. Oh, sorry. So you just go ahead and fill this in. We will have 36, right? 36 different outcomes. 4-1, 4-2, 4-3. Make sure it lines up, okay? That it looks organized, because we're going to use this to answer questions down the road. What is this that we're doing? An outcome table. There you go. Could we do a tree diagram? Yes, but good luck with that. It's going to be very messy. So I like outcome tables. There you go. 36 different outcomes. Did I? Oh, shoot. Sorry, guys. Did I mess up? What does it say up here? 2 4-sided. So quick fix, if that ever happens to you as a teacher, you're like, this was supposed to be 6-sided. Right? You just tell your students that was just a typo. Right? They will never find out. That's the trick. Yeah, I know. I look back, I'm like, wait a minute. This is a 2 4-sided. But this is a 6-sided. Hey, it's better this way, because quite frankly, I can say a 4-sided and a 5-sided, right? Or a 6-sided and a 4-sided. Like I could do whatever, and you just have to adapt this accordingly. Okay. So what does it say here? State the probability of rolling a sum greater than 6. Let's just stop there, not worry about the odds just yet, because this is quite a bit here. Probability of rolling a sum greater than 6. We're first going to make sure we understand there are 36 outcomes. 36 possibilities that these could land on. So probability, I'm going to go probability of sum. I'm just going to go G6. How's that? Sounds like a razor or something. Razor brand, G6. This will be 36. Sum greater than 6. I don't know if you figure this out, but there's a neat pattern that you can find. I'm going to use a highlighter. So sum means adding them up, right? So 6 and 6 would be 12 right here, right? And then look at that. If you go diagonally, 6 and 5 is 11. You're looking up, right? My finger covers everything. 6 and 5, 5 and 6. This is your 11 line here. Go one further back. 6, 4, that's 10, 10, 10. So that's your 10 line. So basically what you want to do is greater than 6, 5 and 1, 4 and 2, 3 and 3. This is your 6th line right here, diagonally like this. Any combination here will give you 6. So greater than 6 is from here, from this line onward this way. Your mind is blown, I know it. That's okay. So this is my 7 line here, but all of these combinations give you a sum greater than 6. So this is greater than 6. So how many options are there that fit that category? How many combinations? You count. I'll count too. How many did you count? 21? You counted 21? Okay, I'm going to go with it. Let's turn that into a decimal. You probably see that you can reduce that, right? 3 goes into both of them. So it's 0.5833, which is 58.33% chance. And if you think about it, it is more than half, right? Like 21 is more than half. So more than half of the possible combinations would give you a sum of greater. So there's a quite a significant chance that that will happen. Okay. Next, which sum is most likely to happen? Which sum is most likely to happen? Probability, we'll figure that out. Let's figure out which one has the most choices here. And if you think about it, if you go, this is 7, right? 7, 7, 7, 7, 7, 7. So this is your 7 diagonal line. Anything below is not going to happen as likely, or anything below that is also not going to happen as likely, right? So it's actually, this is your most likely sum to be rolled. So it's basically, how should we write this? I would say probability of sum 7, like an exact sum. There are 36 chances, and out of the 36, 1, 2, 3, 4, 5, 6 of them give you that sum of 7. And what do we get there? 6 divided by 36, 1.666, repeat it, which is 16.67%. If you were to take 8, for example, there's 1, 2, 3, 4, 5 options for a sum of 8. It's less, right? If you were to go with 6, 1, 2, 3, 4, 5, also 5 options. It's not as, so it's, you can visually see that this would be the best option there. So rolling a sum of 7. Anybody play Settlers of Catan? This one? It's like a board game. There could be a video game of that too. But the 7 is the robber, right? Like if you roll a 7, you get to put the robber on the tile where your opponent is on, and so you essentially block them. So 7 is the most likely one to be rolled, actually. So it sucks when you play that because 7s get rolled quite often, and somebody can block you that way. State the probability of rolling doubles. I haven't done the odds here. I'm going to come back to that. I just want to focus on probability of rolling doubles. Doubles is simply like your 1, 1, your 2, 2, right? So there's 1, 2, 3, 4, 5, 6 as well. This just happens to be the case here. Okay, so I'm going to use I'm going to use this one. This is my doubles here. Yeah. Let's do orange, like this 6 here. Let's say, right, this is a sum of 7. And then, unfortunately, it happens to be the exact same. So probability of doubles is 6 over 36, which is 0.1667, which is 16.67%. I'm going to highlight that like this. That way you know what I'm talking about. And let's go to the outcome table and just say this is your doubles. And this is sum of 7. There you go. Can I ask you to do the odds? Like for, I want you to do the odds for this event happening for a sum greater than 6. And I want you to write the odds for and against rolling doubles. Would you be able to do that? Let's see. Ding, 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 ding. Now we have that song, right? Real quick here. So for this one, the odds would be odds of what? In favor of G6. So that'd be 21 to 36 minus 15. Boom. And then odds in favor and against of rolling doubles. Let's do the 4 because it's the easiest. So we'd have 6 to 36 minus 6. That'd be 6 to 30. This is in favor. Okay. And against, just flip it. Just like a steak. If you like steaks. Whatever. Or a burger. Whatever. Let's keep going. So I want you to spend some time navigating. Remember what I talked about the whole time up until this point. So I want you to expand your knowledge. So a game consists of tossing a coin and spinning a spinner, this one here. How many outcomes will there be if you're tossing a coin and you're spinning a spinner? How many outcomes? What's the pattern? You multiply, right? So you go outcomes would be event number 1. Sorry. And event number 2. There's only 2 events in this case. Tossing a coin, spinning a spinner. Coin has how many options? 2. Yeah. And the spinner? 1, 2, 3, 4, 5. So you'll have 10 outcomes. I want you to make an outcome table and a tree diagram. And so we'll use G for green, H for heads, right? So that's what you're going to use. Do you want me to get you started with a tree diagram? So you basically do this, like I would say heads and tails. That's your first event, and then each one has 5 branches going off, so you got to be careful. 1, 2, 3, 4, 5. The same thing with this one, and I'm going to change my setup, watch, because you need to be able to adapt, right? I'm going to make the tails go further down. Actually, I'm going to do, I'm really bad at tree diagrams, just letting you know. Like the spacing, I'm always off with. So I'm going to bring the tails further down, and I'm going to go 1, 2, 3, 4, 5. And so what do you have? Do it in the same order. Wherever you start, I'm going to start with blue. So you're going to go blue, red, purple, yellow, and green. And then copy that again. It's better to keep it in that order once you started with that. So just go look at my key there, or my first example. So what you do is you make a little line like this off of each entry. And I want you to actually go like this. State the combination. This would be heads, blue. Then you would have heads and spinning red. And so as long as you're staying with this branch, it starts with an H and then it's followed by one of these. So do the same thing, and then you'll do the outcome table as well. And then answer the questions that follow it underneath, and then keep going with page 42. And I'm going to circle around a little bit to make sure you're on the right path, okay? Answers.